Hello everybody and welcome to Handmade here, the show where we code a complete game live on stream. We did some debugging yesterday and I think we are now at the point where, as far as I know, we don't really have any outstanding bugs in our art pipeline stuff that we've done, which means that we are kind of free to import stuff into our game and decorate the world and add entities to the world, which brings us to sort of the part where we have to really start engaging with the gameplay more, again, which is not really something that I like to do because I'm not a game designer and I feel more comfortable, generally speaking, when a game designer is at the helm. And so, you know, we're kind of at the part now where, and I don't know if you remember the end of last stream, we have a giant cat for some reason. So there are some technical things we can do right now. Like I said, I kind of wanted to do alignment point stuff so we can add some stuff to, like, you know, we want to align the head and the body and stuff like that, and we can add some technical stuff in there. But we are kind of getting up to that point where it's stuff I feel less comfortable with. I don't like doing game design oriented stuff. I'd much rather be in a situation like on The Witness or something where John Blow's doing the design and I'm just programming something. That's a lot more comfortable. But, you know, we'll muddle through it, we'll be fine, and we'll focus on the technical issues of it as we go. So what I want to do here is I want to take a look at just what we want to have happen naturally, and then I want to augment our current system to provide that thing. So what I want to be able to do, and we're ignoring the fact that the hero is a cat currently, but what I want to be able to do is place, you know, throughout the world right now, we've got a couple different cats in the art set. 3 of them. We've got a brown tabby named Fred, we've got a gray tabby named Molly, and we've got a ghost cat named Hannah, who's a Burman, and we would like to place them in the world somewhere, right? We would like to, when the game starts up, you know, we'd like to place these 3 cats around the orphanage, and we'd like them to just be available for the cat, and, you know, for the player to come up to. And, you know, maybe when the player hops up to it, we want them to interact in some way, like, you know, maybe they purr or something like this, right? So they're kind of a set dressing for the game, and maybe they have some gameplay ramifications later. As we get into it, we'll see. But basically the idea is, you know, we want to be able to do that simply. And so the question is, how do we make it easy for us to accomplish this task that I've just stated? What are the current technical barriers present in our engine that are going to cause that to not be fluent and easy for us to do? And how do we break down those barriers, right? So again, the goal is, we're sort of taking, again, a Snuffleupagus-oriented approach here. I want to go make a thing that lets me place cats in the world easily. I want that to be as low a friction, as low a overhead as possible. So I'm going to go into the system and try to do so. And then when I do it, I'm going to see what problems arise and try to solve those problems with improved engine capabilities. Now, in terms of, like, one of them, like I said, is already just the alignment fact, and then there's also the scale fact, right? There's aligning and scaling and stuff. That's why our cat is, like, huge and the head is not, right? So we know some of the things we're going to deal with, but we don't necessarily know them all. So I'm going to go ahead and place some cats in the world, and then we're going to address all of the issues that we see, and then we can use that to also place monsters in the world and so on, right? We're going to build up our repertoire so that we no longer have any friction associated with this. Because remember, what we're going to be doing, you know, 50-day episodes from now, as we've got the world up and running, all of our work is going to revolve around these sorts of things. Generating entity structures in the world and programming those entities to do things is the entirety of what gameplay programming is. And so we want to continue, and we want to start a trend now and continue the trend of refining the systems and interfaces to those systems that are involved in that till it's very low friction to experiment and change, because that is what will determine whether or not our game is any good in a world where we had a designer, right? And that's what I'm trying to prepare you for, right? In other words, if you were the engine programmer or one of many engine programmers, hopefully, on some engine programming team, that is what you are trying to accomplish, because it doesn't matter how good your gameplay programmers or game designers are. If the systems that they have to interface with are very laborious and onerous to work with, then they will not be able to iterate fast enough on the design to make it any good. And this definitely, you see this in a lot of places. There's a lot of times when technological limitations prevent a game from reaching its true potential. In fact, this is a little bit separate from the point I was making in terms of entity placements or things like that, but a very good example recently was Red Dead Redemption 2. For those of you who have played it, that game would be 10 times better than it is if it had had a solid technical programmer on the UI system. It's an incredibly clumsy game to play. It feels awful. You end up accidentally shooting people you were trying to talk to and all sorts of other ridiculous things. And again, that's I mean, you could argue that's the designer's faults, and to a certain extent it is, but it's also a technology problem, because if you provide good quality technology for constructing user interfaces, it's more likely that you will arrive at a good one. Whereas if everything has to be micro-programmed by people who are maybe not necessarily even strong programmers because they're more on the design side, you will end up with janky stuff. So again, can't say why that happened, but I noticed it. I mean, it's a game that's gorgeous. I don't know if you've seen it. It looks beautiful. And it's just a lot of fun to kind of ride around the world. But oh my God, when you go to actually do something, it's not, the interface is mind-bogglingly bad. And I just feel like that's a great place where technology, you know, a little technology and dynamic response to the environment and allowing the controls to very smoothly transition between meaning different things that were all very intuitive would have helped a lot. So the player doesn't have to remember, like, oh, if I wanted to take my saddle off my horse, I hold down the left bumper and the right trigger at the same time, and then I push up on the D-pad, and then it's just like, oh my God, right? Like, it's so weird. And so I feel like a lot of times you have to be aware of what you give people to work with will a lot of times determine what they end up with. And while you can blame them for that, the blame actually should be spread around a little bit more, because it's also the underlying technology making it easy or difficult to represent certain things. Oftentimes that shows through. And I suspect that at least in the Red Dead Redemption case, my gut instinct is that there was a little bit of blame to spread around there, that it was not just the design team's fault, but also probably a certain amount of programming at fault that wasn't exposing a rich language for talking about how the UI could work that leads to a very janky manual 15 million button mapped kind of solution. So don't know, purely hypothetical, but you know, I always hate to see good experiences held back by things that probably could have been fixed. So anyway, let's go ahead and jump into the world generator, and we'll talk about this particular thing that we would like to do here. So inside Handmade World Mode, World Gen, we know that we can create rooms and things like this, and we have things like room specs. So when we go ahead and create a room, it has a pointer to a specification that tells us about what that room has to have in it. Now there's a couple different kinds of things that we need to address here. Some things have to do with room-specific stuff, and some things have to do with character-specific stuff, and some things cross both boundaries. If you imagine specifying a room, as we are specifying a room right now, there's a couple different ways you might want to talk about that room. One way we might want to talk about that room is to generically say that certain types of things happen in the room. For example, let's say that rooms in general just had a 50% chance of having a cat in them always. That would be something that would go in something like a room spec, because you would just be saying, look, every time I have this type of room, there's a chance there's a cat in it. So roll the dice, and if you roll the dice comes up this, add a cat. If there isn't, don't add a cat, right? And that's the kind of thing that treats stuff as non-unique. Monsters are a good example of something that will probably most of the time follow that pattern. Like a non-boss monster, a non-unique monster will normally follow the pattern of a room just says it tends to have these kind of monsters in it. It expects the room generator to then roll some dice effectively and come up with which monsters are actually in the room. But it doesn't matter which ones are in any particular sense. It just matters that they adhere to a certain pattern of population, right? But that's not true for something like unique characters. So for example, if we want each of these 3 cats to be a unique cat, which was the original idea in the game, was that these are 3 unique cats, Hannah, Fred, and Molly, they should only occur in one room. So we can't very well add something to a room spec that says there's a chance that there might be a cat here, because even if we did that, we would then still have to have a structure on the back end that checked to make sure it only added each cat once, which therefore leads to a sort of backwards phenomenon of rolling dice every room and then picking a cat from the available set of cats, or none if none is still available. What this does is it heavily biases the random generation about where the cats will be placed towards rooms that are placed early in the placement sequence, which is not something we actually specified, right? Because think about it. Let's say we said there's a 50% chance there's a cat in every room. Well, there's only 3 cats, so after 6 rooms, all the cats are placed, and the other 1,000 rooms in the game will never have a cat. You're gonna see that bias, and players are gonna pick up on it, and it's gonna feel weird, and it's going to be bizarre. It's not going to make sense. It's obvious that there was a technological constraint there causing something to happen that was not supposed to happen. It doesn't feel right. So what we'd rather do is place on a more holistic sense where we say, okay, there are room specs. Those say things that are generic about the room and that don't have cross-room concerns, meaning they don't depend on what happened in another room as to whether it can happen in this room. So we'd rather have something that works in sort of a more holistic sense and can say, we're gonna place 3 cats. After we figure out where all the rooms are, then let's reach in and place the cats, say, at that time, when we have complete knowledge about the entire world and can make an unbiased decision about which room the cats will go in based on information that we now have about the actual structure of the world. And this makes a lot of sense, especially because, especially in the case of the cats, they are things that inhabit the world, and the world does not really respond to them in a structural sense. Meaning, we don't have any plans, or I don't anyway, for saying, well, if a cat is in a particular room, then the room and the things around it should be structured like this, right? Now, you could imagine a certain circumstance where that is true, and that would create a more complex structure for the world generator to have to understand and work with. But in this case, we don't have that situation. The cats are more like just inhabitants of a world that is constructed based on rules ancillary to the cats, and so you can think of their placement as something that's more about looking at the world and figuring out where we think the cats should go, rather than building the world around the cats, which makes them sort of a perfect thing for this sort of secondary placement phase that's about analysis and placement. So what I'd like to do now is add that phase into the world gen, something that allows us to cleanly think about placing unique items and characters in the world in specific locations only once, put that in, have it actually place the cats, and then push that down to the final part, which is any kind of cleanup we need for the asset system, like, say, those alignment points or scaling information that we then want to add to the asset system to make it easy for us to actually create the cat entity, which is a separate issue, right? So I'm going to go through that whole process today. Hopefully we'll get through all of it, but we may stop a little bit short of setting the alignment points because that's sort of another step that's a little bit more involved, so we can maybe tackle that next weekend. So here's the structure for generating a room, and if we take a look at the world gen code right now, it's not particularly good, right? We just sort of started sketching things out, but we do place some rooms in here. And then if you remember how this works, we've got sort of a create orphanage thing, and so I'm going to go ahead and pull it over here so my head isn't blocking part of it. And what we do inside the create orphanage call is we just create a bunch of room specs that are specs for rooms that we want to have exist here. There's such as save slots and the bedrooms and things like this. And inside those room specs, we have a simple setting. Does it have stone floor or not? Which we actually respect. So if you look, we just did that as a test to see if you actually look at what happens when we generate the world here, you can see if I kind of move upwards here, that the bedrooms, which are these right here, actually do have stone floors, just like we said that they should. And so that's actually being respected as the one and only current specification for room that we really use. And there's going to be a lot more there, obviously, as we start making a richer description of what constitutes a room and what goes in a room. So what we want to do now is we want to say, well, okay, so if that's the stone, like the room spec stuff, and you can set things in there, we have a good place for that. We now need a good place for talking about when we generate these rooms. You can see us generating them here. You can see us setting the size of a lot of them, and you can see us connecting them. We're sort of creating a bunch of rules about how these things have to be connected, and then they get laid out, right? We then, at the end of this, would like some way of saying how we might want things to be placed, right? How we might want entities to be placed in those rooms. So, for example, inside the bedrooms, we may want to place particular characters from our character set, right? We have all the orphans who live in the orphanage, and we may want some way of placing them into the world. They would, for example, each live in one of the bedrooms or something like this, or in the kitchen or the tailor's room, right? The tailor orphan would live in the tailor's room, and the baker orphan would live in the kitchen, for example. Live is probably the wrong word. What we really mean is there when you're walking around, right? Baking or doing something. They probably don't live there, or maybe they do. Maybe there's a bedroom there. I don't know. But point being, we want some way to place people into specific rooms, probably. And the way that we would probably do this is at some point after we've created this stuff, like for example, inside Create Orphanage, we do all this stuff to create the orphanage. We also have things like dungeons, and we create the dungeons, right? And so when we're doing these creation things, they return results that we can use. And so you can see in here, when we create the orphanage, for example, or the forest or the whatever, right? You can see us here. We create these sort of results from the spec generator that sort of says stuff like, here's the orphanage. Here's some important rooms that I created. And we might eventually specify all the rooms we created in here, right? So after you call create on it, you can think about it in other ways. I think that's how we would like to approach this, because when we call create world, we'd probably like at the end of create world, when we've created all the rooms in the world, we'd like to go through all of those sort of structures and start tapping into them to create various or to place various things that we might want placed, right? So I'm just going to start by sketching in what something like that could look like. So, for example, in here, if we have the orphanage, what I kind of want to do is take a look at some of the other... I want a way of reaching in there and placing the cats as we go. And there's a couple different ways that I might want to do that, right? One way to do that would be to do it in line with Create Orphanage, if the cats are always inside the orphanage. But another way to do that would be to do it outside, because what if, for example, sometimes the cats are not in the orphanage? Like maybe once in a while one of the cats wanders off into the world, and then that cat doesn't place itself in the orphanage, it places itself in some other world location, right? So if I was to say, look, let's actually record a lot of this information in here, maybe, maybe we want this as something that we can actually record. So, I'm going to say, let's say there's 3 hero slave slots for bedrooms, and then there's some specific other elements in here that we, have talked about. For example, if I was to upgrade the orphanage structure to look a little bit more like this, so it actually records all of the rooms that it has in it, then anyone who wants to touch those rooms specifically or place something into them specifically can do so. So if I grab this and fill it out at the end, I'm again just sort of guessing here, but I'm thinking that might be a nice way to propagate that information outwards exactly as we have been, the entire time. So here's our save slots. Here's the front hall. And so then the other thing that I want to do here is I would like to be able to access these things in multiple ways. So I'd like to be able to access them in ways that allow me to randomly pick from certain types of rooms as well, or do other sorts of things like that. And so one of the other things that I can do is I can make, I can do a lot of different things here, But another way that I can do this is to make one of these, right? Where I can say Gen Orphanage and I get back a set of rooms, and I can, if I want to, actually just give them I don't know exactly how to say that. It's not really a room type. It's more like a room ID, maybe might be the right way to look at it. And when we talk about these room IDs, what I could do is say, oh, you know what? Instead of doing it like that, let's instead say that we've kind of got something more like this, where each of these sort of rooms can come back in a set of rooms, and we just say what each type of room is. So we can do random picking on them, or, you know, who knows what else, right? I'm not sure the best way to place something like that. There's two ways we could do it. One is to set a room type, and the other is and list the rooms. Another is to actually just have rooms by ID. Yet even another is to just have giant lists of these things. I say. And I don't really know. I don't really know which the best one would be. I mean, you can see sort of what I would like, what I'm going for here anyway, is I'd like to place 3 cats. And so, you know, what I want to do is inside here where we say, you know, the same sort of thing where we're like, look, this is where the starting room is. It's the hero's bedroom or whatever. So start laying out from there and generate the world as you go outward. You know, in here I would like to sort of say, let's place some cats, you know? So, in fact, I guess I wouldn't quite do it that way. I'd probably more do something like this, place cat. And I want to pass something there that lets me pass where, you know, sort of the set of possible locations that we might want to place the cat. But, you know, then I'm going to pass which cat it is. And so inside the, sorry, I should say file formats. Inside here, we've got these tag types, and I can say, like, okay, I would like to place, you know, the Berman cat in a particular location. I'd like to pass the tabby cat, and I'd like to place the brown cat. I want to place each of these cats, and, you know, off we go. So I'd like to have a way of placing the cat somewhere, and I'd like to be able to have it pick from a set of locations fairly reasonably. I just don't know what we're actually going to be passing here. So when we write this routine, you know, you can imagine how I would want to be able to write it. Also, I suppose there's probably some kind of a gen placement thing here. Or maybe even just an entity, you know, that comes back. I'm not sure how that would go. Well, it's not going to be an entity. It's going to be the request for an entity, right? Because we wouldn't actually place the entity itself until we actually generate everything, right? It's because we're just saying that there should be an entity here, not, you know what I mean? So anyway, what we would like to do now is have some way of, you know, discussing where this thing actually goes. And we might want a couple different ways of saying that. Obviously, if we knew exactly what room we want to put them in, we would just pass the room. But since we're sort of saying we would randomly want to put them in a set of rooms, we want something that's going to be like the series picker in here. And, you know, the world generator's got a set of entropic series that it can use for this. So we know that the world generator would come in here and that we would use the entropy from the world generator to pick randomly from some set of things, right? We'd want to do a random choice over some set of rooms, like, you know, a room count here, something like this, where we'd say, look, pick a random room out of a set of rooms, like so. Find out what that room is. Something like this. And when you found out what that room is, then we are going to add an entity to the world, to that room, right? You know what I'm saying? Something like this. And that sort of allows us to, I guess this should really be asset tag ID. Like that. This is sort of what we would want to do. And so the question is, how do we come up with this structure? You know what I mean? My gut instinct, which is often wrong, but is always the place to start, because what else? Where else are you going to start? Is that maybe what we would like to do is just maintain picking lists in the world generator, and then you randomly pick from a picking list. So, for example, let's suppose that every time one of our generation routines that's creating structures in the world creates a room where it thinks a cat might want to hang out, it would create a cat placement record that is saying you could place a cat here if you were so inclined, right? Then, when we go to place a cat or anything else, a mini boss or a boss monster or a treasure chest or whatever, you could imagine that system being somewhat generally useful, meaning you would just say, all right, every time the generator generates something that could be used for a particular purpose, it adds it to the list of things. And I can't say I can think of any particular reason not to do that. It seems okay. I guess what I'll say is I'm going to experiment with this a little bit and let's see how I like it. I may not like it, and I reserve the right to therefore stop doing it at that point. So I'm going to call, maybe I'm just going to call this a gen option. And a gen option, I think what I want to do is something like this, where you basically say, okay, I've got a gen option type, and the option type is going to be like this thing that says like gen option, you know, cat or something. I apologize for this being kind of a little bit ill-formed, but it's ill-formed because I don't really know what I want to do here, right? But like, imagine something like this. Where I just sort of made some chains of stuff, and I mean, I guess I could also make them be actual arrays so they'd be easier to pick from. It's pretty hard to say. What I'm thinking is, if you've got an array, you can pretty easily pick a random element from the array. If you've got a linked list, it's much harder to pick randomly from it because, I mean, on the one hand, you can sort of do it in an efficient method by randomly sorting the thing ahead of time and then just taking the first one. But that random sort is a little bit of an issue in and of itself. Uh, hmm. And the other thing that I think I want to be cognizant of is when you're placing these things, you don't want to place them all in the same place. So when you place like a cat somewhere, you kind of want to talk about an option having been overloaded to a certain extent, which I guess you can sort of do. I'm just going to go with it. I'm going to say, arbitrarily speaking, maybe there is a gen option array, and maybe that has an option count in it, and maybe it has the options statically, and maybe I have a set of those, like so, and that's just all purely hypothetical, right? So that's what I would have. And inside this, the gen option would really just be a pointer to a room. And that room would be the thing that gets whatever we're talking about here, right? And I might furthermore try to flag that out so that we have a notion of what is in the room. So we would have like something like this, where the options picked in this case get OR'd in from the set of options that are available. And I think that works reasonably well. At least my first inclination, right? So basically, every time we pick one of these things, we randomly select one, and then we see if it's suitable. And if it is, we OR in the flag here. That seems okay to me. So for example, gen option cats would be one. Maybe gen option orphan is another. You know, like we put one of the orphans in here. Maybe gen option, trying to think of what they would be. They'd be like, a mini boss or, those sorts of things, right? So I think we would put sort of the stuff that we place around in that way would create, the options would be sort of created in the list, and then we would pick from those options and fill them out. Seems okay to me. I don't know. Maintaining the arrays as the generation goes on seems like a kind of a pain in the butt. Because you want to be able to both pick quickly from them at random and also just add to them, which there is no really good data structure for. I mean, there's better ones probably than an array, but maybe it depends on what you're optimizing for, whether you're optimizing for picking or adding, but I don't know. So I don't know. That's something. It's hard for me to really get too excited about it because I'm just not sure yet. But that's roughly what we're talking about here. So what I would say is, there's going to be something here which is like, oh yeah, maybe we do something like maybe we would do something where we pick the option. I just can't decide if you should remove it or not. You probably do. So we'd probably do something like gen option pick option, and it probably just returns the room. So we're like, give me something. I just want you to give me something that I can place this thing in. I'm gonna look at it, and maybe there's a corresponding one which is like, hey, this, I'm gonna tell you that this thing is now an option for placing that thing. So I can pop an option off at random, and I could push an option on, and those two things both have to be able to occur pretty much at any time, I'm just going to say. And it's going to be ugly because it's going to waste a ton of memory, because I've got to make like these arrays and stuff. It's not compact. But I guess that's just going to have to be okay for now. And if we really need to do something more creative later, we can. As necessary. So then when we want to do something like place cats, we would really just do something like, oh, all right, so I need to know what room the cat's in. So I just do a pop option and I say, I need you to give me a place where a cat can be, and maybe we do something a little bit saucier where we also say like, require and or allowed and disallowed. And so what we would be saying here is like, well, we're gonna pass you a bit vector that basically says here are the things that have to be in there and here are the things that can't be, or something like that, right? I mean, really, I guess what we could say is a more complete version would give us the full flags. So it would say, yeah, you know what? I don't really want to do it quite that aggressively. Yeah, I don't want to do that aggressively. So here's what I'm thinking. I was thinking, oh, you could pass some stuff in here that would kind of let it discriminate and determine what room it wanted to place them in. But I think that's going to be a lot more touchy. Like, it's going to involve inspecting the room in fairly complicated ways eventually. So that just doesn't really make a lot of sense. So I think what makes more sense is to just say, look, give me the most important option here, right? Like, here's the gen option type that I want. I'm going to pop these off, and I'm going to pop them off in order probably. So I think, I'm not in order, but I'm going to pop off potentially multiples as I look through and try to find a room that's suitable. So really, it's going to be a little more complicated than pop option. What it's actually going to look like more is like an iteration, if you will. So it's going to look more like this. It's going to look like struct gen option iterator. And what you're probably going to do here is inside this place cat thing, you're going to say like for, gen option iterator, begin option search or something, or iterate options. And you're going to say, I want options for some place I can place my cat. And then you're going to iterate over what comes back. And maybe this is known to only work this way. Like, maybe we don't really need anything else. So it's just going to be like, yeah, we create one of these iterators, we iterate over it. This will give us our options. For each option, we can look ourselves. And we can say, all right, so here's the room that it's saying we should put it in. Here we could do... To do Casey, check this room to see if it meets our other criteria, whatever those happen to be. And then we can either, well, I guess then what we would do here is just say, all right, now we're done, right? So we would say like finish or something, right? I don't know. Something like that. So this way we can iterate over a number of random choices, looking at them, and the system understands that we're doing that, so it won't keep picking randomly and giving us back and like searching through rooms we've already searched through, right? It'll always pick new ones until we run out of rooms to pick. And so I feel like that would be the key, right? So we'd have gen entity results, and we would return the results here. And in here we would place the entity. And so this really is just an if1, but someday we're saying it would actually look at something. And then it would place the entity in the room. And I think that's all we really need there, right? So we have our room index and room choice stuff is not necessary anymore. That's going to be coming from this system. We can iterate over all the options where we might want to place a cat. We can do additional checking to figure out whether a cat really belongs there or not. And yeah, that's the end of it, right? Seems reasonable to me. So this goes inside because, you know, if for some reason we didn't find this room to be acceptable someday when there's an actual criteria being evaluated in here, then what we would do is we wouldn't finish, so we'd keep looking for new rooms, right? So I think that's how we want that to work, and so really this looks like this. And then each of these is just sort of a service call that allows us to complete that iteration cleanly and just makes it easy to use the semantics of it, right? Okay, so there is no pop option. There's only a way to add an option and to iterate over options. And then the system is responsible for doing something meaningful with it at that point, right? And we'll figure out how I want that to work. But I pretty much already know how I would have that work, but we'll kind of look at that in a minute. So that seems reasonable, and we'll stub it in for now. So here's the result, right? And what I'm going to do is just say, all right, let's just assume that this just always pops a room right now. And so it's totally broken, doesn't actually do at all what I wanted it to do yet, right? So it just has a room on here. And so the result of this function is just, is the room valid? And in order to advance it, it just sets the room to 0. And when we go to finish this, it also sets the room to 0. And so there really isn't, so this is, you know, I'll even put this in here, not yet implemented for real. So really I'm just stubbing this out and not really making an actual function out of it. And we'll talk about that, well, we'll actually implement it a little bit later. So when I iterate options here, what I'm going to do is I'm just going to pop the first option off of the option array. So I'm going to go ahead and say that if, well, first I'll get the option array in question, which is here. So I'm going to say, all right, this option array is whatever the option arrays are plus the type that you asked me for. I'm then going to say that the array, you know, it's got an option count. So if there are options in the option count, then I'm going to pop the back one, like so. And I'm just going to grab it. So the room in this case is just going to be the options, and we're going to say that the in here, when we get the gen option array, it's got a pointer to the options. The first one, the last one in the list, we're just going to take whatever that room is and use that. Make sense? So that is sort of the stub out that just says, well, it doesn't really do what it's supposed to do, meaning it doesn't really allow us to pick multiple rooms or randomly pick rooms or anything else yet. It just kind of gives us one room and places it. We're going to get it working with that, and then I'm going to come back and change it to allow that to work better, right? So that leaves us with push option. Push option needs a way of creating something meaningful here in terms of option arrays. And again, this is going to be some pretty tasty bad code, and that's okay, because I don't think this is going to be a particularly important part of the system anyway. But we're just going to basically just add these in blocks of 100 or 1,000 or something and call it a day, right? We're not going to do anything else interesting here. So what I'm going to do is the same thing I did before. I'm just going to grab the array in question, and I'm going to check first to see if the maximum option count has been exceeded. So if the option count is less than the max option count, and I'm kind of writing that only semantically, this is the case where we could add it. But if the option count is equal to or and greater than, should never happen. So, you know, and really it should just be that that is never the case, because that's just totally borked. So assuming that the option count is equal to the max option count, it means that it's full and we can't add any more. That could happen either because we've never allocated any of them, or it could happen because we've used all the ones that we have allocated. So what I want to do there is say that the max option count is going to get increased by some amount. That amount is just going to be 100 because I pulled that out of my butthole and we're just going to use it. Then what I'm going to do is say that we'll reallocate the array. So we'll basically say that we have a new option amount, right? New options is going to be equal to an array that's pushed onto our temporary memory. And all we're going to do there is say, inside our temporary memory that we're using for Scratch, let's just go ahead and grab a, we'll just lemon grab out one of the, you know, a block of this many, however many we want. We'll lemon grab that many gen options. Again, really piggy and wasteful memory here wise, because we're not even going to return the old array back to the system for any particular use, right? So it's, you know, we're only using it at generation time, however, so it's not clear that we'd ever really care. And we will flush all this before we actually start running the game, when we might care about the memory overhead, so it's probably not an issue, but we'll see. So anyway, we're going to increase the option count, and then we need to copy the old array of options. So we just say, okay, we've got whatever the option count was. We need to copy our array of options. I do have a copyright, don't I? Yeah. We're going to our old array of options to our new array of options, and then we're just going to make that the new array. That allows us to push as many as we want on, and it will continue to grow. Again, don't know that we really care about this one way or the other, but we'll find out later whether we need to be saucier here or be more efficient, right? Maybe we do, maybe we don't. So now that that's done, we can just actually place a cat. The problem would now be that we don't have a way of recording that we want specific entities to be placed into those rooms. So we now need some way of having that be notated in the world generator's standing structure that works with whatever's in there. So inside here where we have a gen room, we kind of want a way of attaching entities to it, because like right now you can sort of see, by the way, that means all of this is not necessary anymore, so I guess that means that was a waste of time. Sorry about that. Maybe we'll still use something like that later, I don't know, but probably not, because we did something else. So there's really only these two. Just go ahead and okay. So essentially what we want to do here is we want to expand the notion of the room idea to include entities that have been placed specifically in this room and which must be placed in the room, right? Meaning that the outer scale system said, hey, this, you gotta put this entity in here, you don't get a choice, so Mr. Room Generator thingy, go ahead and do that, right? So if we say gen room entity, but really we can just say entity probably, because this doesn't need to be specific to the room. These can just be in the rooms as a chain, I think. And so they would just get placed in here, and these entities would just kind of stack up. And then we'd tag them, we would basically have some set of tags in there. And those tags would get carried forward as a way of specifying what the entity was. I'm not going to have a variable list. I think that would kind of be a waste of time. So instead, I'm just going to say that we have a sort of a gen entity tag here. And that just has whatever the asset tag ID would have been and the value of the tag. And then there's just going to be some number of tags that entities can have. Maybe it's 8, maybe it's 16, I don't know. But we're just going to place that many of them in there. Let's say it's 15, because why not? Because then we have a next, this is a balanced entity. At that point, it is exactly 16 times 8, right? Because we've got one 8-byte thing and 15 8-byte things. So it's 16 times 8-byte things, which is 128 bytes, which is 2 cache lines, everyone's favorite number of cache lines, because it's actually the minimum number I think Xeons pull in or something. Anyway, doesn't matter. So we can place these throughout the room, and we can just stack, we can place them throughout rooms and stack them up, and then when the room generates them, it'll place them in there somewhere reasonable, hopefully. We'll have to figure out a way to do that specific thing, meaning how we're planning to actually make that work, right? So let's see here. If we were to do that, then we've got an add entity call that will have to work with that system. Let me see here. Here we go. So when we call that add entity call, that's going to return one of these entities. It's not really going to do anything specific. It's going to place it presumably in a room, but I don't know whether we actually want to do that or not. I feel like you'd probably want to do something more like this, where you just said, okay, place an entity in a room, and then that inserts it into that list, as more of a thing. So that seems a little bit more sensible to me, all things considered. So then we would basically say, all right, the room first entity equals this entity, and of course we need to preserve that list, so off we go. Those get stacked up into the room. Everyone's happy. To add an entity, no big deal, right? Here's the entity as a result. That's just a push direct. on the temp memory, because again, this is all just a temporary infrastructure we use for analyzing the structure of the world. So we just want to grab one of these in there. We then want to take a look at the, well, I think it just automatically clears it, so really that's it, because we wouldn't do anything else. And then, I don't know, it would be a lot easier for us, I suppose, if we had some extra stuff in here. So I might say, you know, maybe there is a tag count, and maybe there's a flags field, you know? I don't know, these really don't need to be quite so large, but, you know, I'm just saying maybe we do something more like that. And that way when you add tags, it's just quicker. We'll see. So anyway, then we've got the notion that we want to add tags to these things. So when you add a tag to an entity, again, you're just passing the same set of stuff in. Here's the entity you want to add the tag to. Here's the asset tag ID, and here's the value. And so that's just going to make sure that the entity in question only has a certain number of tags. So it's going to want the tag count to be less than the array count of the entity's tags. And then it's going to say, okay, the entity tags are added to like so. In this case, I should probably write it this way because we want an actual pointer of the tag, and then I'm going to take the tag and set the ID and set the value. That pushes the tag on. So now we can place entities, we can put tags on the entities, we can put them in particular rooms. In this case, we're going to do that right here. So we're going to place the entity like this, and we're not going to pass it there. So that's all we're doing. And once we're done with that, let's see here. Sorry, hero bedroom. We really just have to go in and make it so that these things actually get placed in the world, meaning when somebody actually reads that list and sticks the entities into the actual room. You know, other than that, not much else we have to deal with. Let's see here. Okay. Here's our option type. Just wanted to return that in case people want to fuss with it after the fact. And off we go. Okay. So now we have the ability to place cats, which is something everyone wants to be able to do, especially shelters. And there's an important difference here, which is that one of our cats is a ghost. So this is Hannah, and she's a ghost. So we're going to add the ghost tag to Hannah because she died a few years ago. It wasn't great. Anyway, so once we've added these entities in, we're now almost done with the system for placing entities throughout the world kind of however we wish, and then the system can respect those in different ways. We still have a couple things we haven't done, and that is adding options for when rooms can be placed, or when things can be placed in various rooms. So I feel like cats probably wouldn't be in the hallway, and I don't know that the cats are going to be in the save slots. But otherwise, they could be in a lot of these places. So I would say I want to do, what did I call it? A push option? I'm going to call it add option instead, I think. So I'm going to say I want to add an option for the main room to have cats in it, right? And the other ones here would be maybe the bedroom A, B, C, and D, maybe the tailor room, maybe the kitchen. I don't know if I want them to be outdoor cats. Maybe only one of them is an outdoor cat. I'm not sure. Or maybe none of them are. So I don't know. But I think that's mostly it in terms of where they should probably be. At least here, right? So I'm going to add these options here where we basically say these are rooms that the cats could be in. And that seems reasonable. So then inside the world gen code, right, we had a push option. I'm going to call that add option instead. And I'm going to grab this stuff and put it up above because where all this stuff gets used, right? Actually, maybe even higher than that. I think this is kind of like, you know, it's like this kind of thing. So I feel like it kind of belongs more up here. So anyway, that means we can add options to the world, right? I think I like that syntax better too. I think I like it better this way, so I'm just gonna make it reversed. But that seems good. So that adds those options, and then it will pick those options to put the cats in. And so I think if we run this, actually, it will, in theory, place the cats, at least once we debug it. Oh, and that assert should be greater than or equal to, sorry. I'm sorry, less than or equal to, right? It should be assert that. It's really assert not the thing that I was saying before. So now it should, maybe in theory, once we debug it, it'll place the cats. We won't actually see any cats. And the reason that we wouldn't see any cats is because the actual entity list never gets processed by the room generation code, so we will have to add that. It looks like for some reason we didn't get any cats. That's really disheartening because we would like more cats, right? So let's find out why. I'm also going to switch to debug mode to make it easier for me to step through. Visual Studio doesn't really do a very good job of stepping through release mode code, unfortunately. So let's go ahead and oh, I know why. I don't even really need to step through it. We expanded our array, we never actually put the thing in it. So we still need to do this, right? So this allows us to add an option, and then we can make that option be the room in question. You know what I'm saying? I'll probably return that in case we add parameters to it that somebody who adds an option wants to be able to touch. So that should add our cat, like our cat request records. So there we go, we placed Hannah. So now all of our cats are like recorded as being somewhere in the world. But we, inside the room generator now, need to actually put entities in when they're requested. So, you know, I'm going to take the simplest possible way right now, and we'll add much like this room. This is completely unworked on. The world generator is starting to become a little bit more real. Like there's actual logic in it, and it's sort of starting to look more like a thing that's a real system. For doing what it does, the generate room is still just garbage. And so I'm not going to spend any time on this part here yet, because we're gonna do this whole part much more seriously at some point when we get to actual room gen stuff we care about. And so this, I'm just going to do the stupidest possible thing, which is to say that here, when we do, we've got on lamp, right? On boundary, on connection, so on. So anytime we add a traversable, right here, I'm going to add an entity if we've got an entity to add, right? So the entities that you add to a room will just literally stack up along the top row, well, in this case it'd be the bottom row, of the room. and that's just where they'll go. Because again, I don't care, and I just want to make sure that the higher level code's working. Eventually then we'll get into room shaping, which will be like a different thing that we'll do when we get there. So here when we do the traversables, we know we can put an entity on this traversable if we want to. So that's exactly what I'm going to do. We'll start out by opening at the start. We know we've got a particular room. We know we have like an entity or a pending entity, let's call it. So we know we've got that first entity. It could be 0, but that's what we're going to check. So if we're not on a lamp and we add the traversable here, we're just going to say, look, if there is a pending entity, we're going to add the pending entity. And then we'll advance to the next one. So if we want to add one of these entities into the system, we need to add whatever the type of entity is that we're actually looking at here, right? So in the case of a cat, we have to actually add the cat. So again, we've kind of got there's probably an additional piece of information that we'll add to our gen entity, which is like what the generator call is that adds this thing. And I'm not sure how I want to do that, but I don't really care right now because that's not really, again, that's something that we can kind of address later when we have more stuff we care about, because there's really no information at the moment about how we might want to do that. So let me just go ahead and jump up here and take a look at what happens when you add entities to the world, right? Looks like this. So what I want to do is I want to be able to add entities, and then I want to be able to add tags to the entities that come from the list of tags that we specified there. It kind of occurs to me I feel like we already... Okay, here we go. So here's, like, for example, the code that adds a Monstar. So if we want to add a Monstar, it would look something like this. So I'm pretty sure all we really want to do is just make this a little bit more generic, and then we just go from there. Like, if we want to add a Monstar, like, it is a little bit harder because, like, things like snakes that occupy multiple squares are going to be harder for us to place. So we'll have to think a little bit harder about those, but most things, since they only occupy just the one square, would be really easy for us to place. So I'm going to start with the simpler case, and we'll have to kind of grow it out to work on the harder case. But if we look at what happens when you place an entity, it looks actually quite simple. So we've got like the world position P and the standing on place that it's occupying, right? And so it looks like you can kind of just do this, where you say this is where the thing is going to be in the world, and this is what it's going to stand on. So it looks like we kind of already know the entity position, right? It's this thing. And so it's going to get placed down here by that call, or this thing would get placed down here by that call. Anyway, I don't know why we would have to specify a P if we already specify a standing on. That's a little opaque to me, why that would occur. So we'll have to think about that a little bit more, because I don't understand why you would need to do that, and maybe you don't really need to do that. But that's sufficient. So in this case, if we have a pending entity, we're just going to like place the pending entity here, and off we go. Yeah. I mean, the other thing I guess I would say is maybe we want to leave that up to this system. And if that's the case, then what we'd like to do is really have something like this. So we know that this is what we would place, or how we would request the placement of an entity. This will do that addition and add the various pieces here. Like so. I don't really know how much more of this there would be for a cat. It's probably just the body and the head. But this is what it would look like. I don't really know that it has hit points either, but, you know, we'll cross that bridge when we come to it. So this is a brain cat as well. I'm not going to add a brain to it at the moment, but eventually we probably would. And that is pretty much all there would be for adding a cat. That means, although we'll call this directly here because all of our entities are cats, we will then just make this a more abstract way of specifying what we actually want to place a little further down. So here's how all of these functions should, I believe, work. And so then we would say, you know, entity equals add cat. I don't know that there's anything really else. This is like the placed entity, add cat. I don't know if there's anything else we need to do other than spam the tags on there. So in here, we wouldn't need to do the occupying because that gets done in here. And we wouldn't need to do the place entity because that gets done in here. So really all we would be talking about is adding the tags that exist on the pending entity. So we'd really just do something like this. Where we take that array and we just say, all right, for every for every one of these, we just push them on. Now, looking here, you know, I mean, it's really just pretty basic, right? We would just say, here's a gen entity tag. It's the pending entity tags plus the tag index. We would then just call add tag on the placed entity, and we're just effectively copying these over. So that adds all of those tags to the entity and after they've already been placed. And in terms of adding the cat, we just need to pass it the traversable, which I guess you pass like that. I don't actually know how you pass that, to be completely honest with you. That we'll have to see. But looking at add cat here, right, we need to pass the other things that we do know what they are. So the region, the P, and the standing on, I just don't know how you get a traversal reference because I honestly don't remember how you make those. Traversable. But let's try and find out. Not seeing a lot of information there. So you've got an entity reference which says which entity we're talking about here. And then you've got an index, which is the one inside the entity. So it's pretty easy to make one of those, but I don't know, again, like that system's kind of old and we haven't really done a lot with it. So I'm not sure how that wants to be done. I mean, I guess it would be done like this, right? Where you say the traversable reference is just 0, 0, and the entity that we're talking about here is this one. Maybe? And again, I'm not really sure. The entity reference in this case, I guess looks like that. And the only thing I don't know is, so the entity ID though is not filled out in this case, which is less good because we don't really know what that entity ID would necessarily be. Although I guess we can just fill that out as well. Is there a way to just reference an entity? Like, don't we have a function to like make one of these? This stuff needs to get overhauled. Yeah. So I know that's kind of seat of the pants there. I don't love any of that stuff. I feel like that stuff could get cleaned up quite a bit now, but one thing at a time. So placing one of these things would work like this. And this call will be something that I think we then turn into a function pointer. So when you place an entity, you can just say, this is the function I would like to create my entity at, at such time as we actually go to create it in practice, right? So now we probably will have to step through the codes somewhat to find out if these entities are getting placed. But it looks like they are, right? Because if I go now in here, you can see that we've got Fred is there, right? Although there's some really weird stuff happening with I don't know if that's Z fighting or some other weird thing that's happening with him. Let me go ahead and... so there's some weird things happening, although, and it looks like really most of it's just that he's not structured particularly correctly, so he's kind of flattened on top of each other, which is not particularly great there. But it looks like we've placed two cats. For some reason, we're getting both Freds, which is not correct, right? We should have been getting, so there's a Hannah. But we should have been getting a gray tabby, and we're not getting a gray tabby. So we got all three cats placed, and that system does seem to be working properly, except for the fact that we're not actually seeing one of the cats. You know why? Because one is a gray. It's because we didn't pass those tags. We just said tabby. So actually that's our fault, right? So when we go to place this tabby here, what we really wanted to do is probably specify in here, maybe even take this out. So we may want to do like a place cat and say that it's, a Berman. And then here we want to say that this is a gray. And here we would want to say so. So now we've got one ghost Berman, one brown tabby, and one gray tabby. And I guess technically, if we're going in the right adjective order, it would look like that. That's not a volume, that's an entity. And so now we are correctly, I think, doing all of the entity placement there. So when we start off in the world here, we do have, so there's one Ghost Hannah, there's one Brown Fred, and then there's, well, no, we're still wrong there. Yep. Typos abound. The code can only be as good as the parameters you pass it, folks. So let's try one more time. So there's a Molly, there's a Fred, and hopefully we'll get a Hannah up here. There's a Hannah. So that's good. And at this point, we've got that entity placement stuff that seems to be working roughly the way I would want. So really what we need to do now is just expand that slightly to have the notion of a call in there that's going to be specific to the type of entity being placed. So in here where we do gen entity, we're going to have some kind of a callback, which is like, you know, type def entity star, and I guess I'll do my standard define trick here, which is just, this is like an entity generator, or like this is a create entity call, something like that. You know what I'm saying? And so one of these is just something, it's anything that returns an entity and takes the same parameters as our place cat call, right? Oops. Where is our place cat call? There. Nope. I'm sorry, not place cat. Add cat. So it's basically that. So you pass it a sim region, a world position, and a traversable that it should go on, and you know that's what it does. So that is going to be on the entity struct. It's like a thing that we then have gen create entity, and then like this is the creator. And so when we make one of these, we're just going to say, look, that's the function that you actually want to call. And so in place of calling add cat here, what we're going to do instead is call whatever the pending entity said we should call to create the thing. And that's what's going to create it. So now if we ran this, we would just crash, right? Because there is no, it's just a 0, right? So we would try to call as 0. So in order to restore the functionality, but now we've made it so we can do whatever we want, we just need our our add cat call here to be a gen create entity call, add cat, like so, so that it fits the particular function prototype that we're looking for. And then inside world.gen, whenever we do a place cat, we just need to make sure that the thing that gets placed when we place cat knows that the thing should be a cat. So I'm going to say that the add entity call, generally speaking, to encourage good behavior, takes an create entity callback. That's what needs to do the entity creation. And so that will always be set, so we don't end up jumping into no man's land. Okay, so we then need our calls like add cat to be things that are generally available. And since that's sort of, since we have like world gen, room gen, I think at this point we need entity gen, right? So I think we need like in the code directory, we need like handmade entity gen .h and .c. Here's our .h. Here's our .c. And so all of this stuff should really go in there, in my opinion, right? So all of this, lamps, familiars, blah, 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 right? Whatever that is. That all goes in here. And this stuff is given like primacy over when we're doing the gen stuff. There's an entity gen that goes in here, and the same is true in here, right? And then we can move similarly the stuff here out. Let's see, where did I have that stuff? Right here. So this stuff that was previously, you know, stuffed in there is now its own sort of space that can exist outside of it. Now everything should kind of be properly bucketed so we can think about what we're doing at any given time. So that allows us, I believe, to just make whatever we want. So we can make things that add whatever random stuff we want to add, and it will just work, which I think concludes the placement series of things. So now I think we're on to the proper construction side of things, which is to say that that does not look like a cat because the head and the body, well, first of all, it's enormous. Let's start with that. The head and the body aren't lined up right, blah, 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 right? So now we need to work on the entity construction part of this process, right? So that's something that we kind of want to work on here. So let's pop over doing that. And this is where I said I might stop today, but we got about 15 minutes left. So we might as well just start with some of the light treatment that we might want to do here. And we can then move on a little later to whatever we want to do that's more serious later, right? So we can start with some basics, which is that, well, you know, the scale of cats is just going to be the scale of cats. So really, you know, whatever this is supposed to be here just is what it is. So at some level, we don't really have to do much work because I think our system already allows us to make things as big as we want them to be. And so if we just scale these things a little bit differently, we would end up with cats that are appropriately sized, right? And similarly, if we float them a little bit above, you can see they're kind of interpenetrating there. If we make them higher up off the ground, that'd help as well. And again, I'm not really sure what we want to do about that necessarily, but for right now, what I can do is just elevate them up off the ground so we can see them. So this will be both of their pieces are just kind of floating above where they are. I should probably instantiate them in our room. It would make them easier to see. But so there you can see, let me walk in there. There you can see a more normal looking Fred, right? And there's a couple of things that we want to be able to do there. His body, I'm sorry, that's Molly. So her. You can see that the body is now a more reasonable size. The head maybe isn't exactly. And so we might want to adjust those two things separately and just kind of get the relative sizes correct. And I could even position them correctly after that. But that once we get to that gets more into the sort of align point stuff that I wanted to talk about separately, which we can then go from there. So let me go ahead and do two things. One, let me raise the head slightly above the body because it should be, right? And two, let me make the head a little bit smaller than the body because, you know, it should be. And there's a couple of things we may have to do. We may have to respect sizes a little bit more than we're doing right now. So I may have to go look and see how we want to do that as well. Because these two things, it's hard to say. I don't remember if we're respecting sizes correctly and things, so we'll have to see about that. Anyway, so looking in here, right, I feel like the head should have been raised up a little higher, and it wasn't. I'm not sure why. Right, that should place the head higher up, because that's a Z offset, I thought. So like that, for example, it should be clearly above. And the fact that it wasn't clearly above is a little odd, so I'm wondering if maybe is that not being used somehow? And again, this entity stuff, we're going to have to go in and clean it up because it's kind of always been an afterthought. So now that is, you can see that it's got a Z offset now, right? Floating up there. So I'm not sure why that wouldn't have been sufficient. I think even 1.1 should have been enough to see it floating above. And I guess part of that's, you know, the Z obviously is modified by the Z bias program and so on. So there's that. But we'll see. So anyway. Yeah, so that seems a little bit more correct now. And so, yeah, there's the cat. And it seems fine. Certainly more fine than our current cat, giant weird hopping cat that is not supposed to even be a cat. So I think mostly the stuff there is now about aligning things in particular ways. So I think that's a good place to stop for today. Just trying to think if I should bother going further into that. I don't feel like I should. And you can kind of see like we're getting some different weird things there, like different size things. So I think we want to respect size more. I should probably go do that. Maybe I could do that in 15 minutes just to get the size stuff being correctly proportional to the sizes that are in the files. So that's something we would like to do. Yeah, so we can think about that. But, you know, we're kind of opening up a bunch of things we can start doing now, and I'm not sure which of them we want to work on first. But one other thing that I would like to do maybe is just see here about inside, like, inside the actual system that renders the entities. I'm thinking also, you know, if the thing's a ghost, it should get alpha or something. I mean, just as an example. And we probably wouldn't quite do exactly that in the future, but, you know, something to that effect. So when we go to do an entity render here, what I would like to do is look and see, you know, if this cat is a ghost, then it's going to have its alpha affected by that. So one way to do that here would be like, say, hey, you know, we did whatever this match vector here is tells us if it's a ghost or not. So we could do something like, I don't know if there's an alpha value that comes through here. Probably not. So you can see there's probably a color right here. And what we could do is say, look, color is going to be times equals whatever the tag value is on ghost for this entity. So match vector and the ghost tag. So just looking at whatever that is, 1 minus the ghost tag is going to multiply in here. So if something is a ghost tag, you know, it would ghost out. Now, I don't want it to become completely invisible when it's completely a ghost. I want it to maybe be, you know, just a little bit invisible when it's a ghost or something like this. So we'll, you know, it'd be something more like that. So that way, in theory, now ghost cats are translucent. I mean, that's what you would expect a ghost cat to be, I would think. I don't really know, but let's just assume. And now they are, right? And I think that's better because, you know, if I go into a room and I see a ghost cat, that's what a ghost cat should look like in my mind. A ghost cat shouldn't look like a regular cat because ghost cats are ghosts for a reason. So again, just some little things like that that also should be taken care of. And so anything that's a ghost in the game should probably have some effects on it. That's just a simple effect thrown out now. It's probably not the one we'd use in the final, but it's close enough for now. So yeah, I think we're down to align points and sizing. Looking at sizing, I think, is the first thing I would want to do. So the thing that we've got that currently happens with sizing is when we push an actual sprite on here. Let me see where that is. Here. So what happens here where we do the bitmap dimension stuff, right? You can see us sort of playing with it here. We don't, well, there's a lot of things we don't do. when we go to push a bitmap on, what you can see happening is we use the bitmap dimension to figure out what the aspect ratio should be to make sure that we always get the aspect ratio correct, right? And this is a good thing. What we don't do is figure out how big this thing should be based on any bitmap dimensions, right? And that is potentially a problem, and potentially not. It really depends on how you want to look at it. So if we imagine that most art assets in the end would want to be scaled up to maximally put detail into the space available for the texture, then really what we're talking about here is some intrinsic value that tells us how big this thing would have been relative to other things its size, right? Relative to other things' sizes, I should say. So what we're really talking about is we want to have something in addition to the width over the height, which tells us how to correlate those two things. We would want something that tells us how to correlate the incoming size of the thing we said we wanted versus the size the thing should be according to the art assets, right? And this is just a way of saying, look, if I say that something should be 1.0 in terms of scale, well, something that was small at a scale of 1.0 and something that was large at a scale of 1.0 should come out to different sizes. That's really the only sane way to have the game treat art assets uniformly, but have them come out different sizes based on how big they should have been in the input. So right now we don't have that piece of information, and we kind of need it, right? We need something that tells us what that was, otherwise we can't really process it. And if we look back at our file formats, right, then what we have is we have a dimension of a bitmap which says how big the bitmap is in terms of storage area, and then we have an align percentage, right? We should also have a width over height here, but I guess we just get that from this dimension. So nowhere in here do we actually store any information about how big the thing should have been, right? We just don't have that information. And it would be nice if we did have that information, because we'd like to ideally have a way to adjust sizes of things based on whatever their input size was. Maybe, or maybe we just want to be able to do that sizing after the fact, right? That's my thinking anyway. So I feel like we really want an additional piece of information there, and that additional piece of information is like a scale factor that gets applied. That's what I'm thinking. So roughly what we would do is we'd say, all right, what was the input size in this? Well, actually, no, we probably wouldn't do anything. What we'd probably do is we'd just import the data as we imported it, and then we would size the thing ourselves on import till we adjusted the size to be what we wanted it to be. You know what I mean? That's probably what we would do. And then we would just say, look, that's the sizes. So the alignments and the sizes would just be things that we adjust when we first import that asset in. And then the asset, even if it gets updated, would just retain that size every time you re-import it, right? So I think that's good. And I think that's probably what I want to do. I'm not going to tackle that now, so I think we are towards the end, so I'm going to go to the Q&A. and we will tackle that stuff next weekend, when our goal will be to place, I guess, most of our entities into the world as examples, and get their sizes and appearances to be correct. Jim says, would or could you add the values of the cat pieces into the big data list and from there drag the values to live edit the cats? I think you already made those features long ago. Yes, that is actually probably roughly what we are going to do, something along those lines. Do you have a video where you talk in depth about the construction of MeowHash? I didn't find anything on YouTube. No, I have not put anything on MeowHash video-wise, but it's pretty straightforward if you look at the code. Are you offended that we named our cat Muratori? No, I'm honored. I love cats. Cats are awesome. So if there's a cat named after me, I am pleased. Can you talk about some of your plans on the AI of entities and what options you're considering? So there's not really going to be any AI on entities. So entities are supposed to be arcade style, if that makes sense. So they're generally supposed to do patterns that the player can like predict. So to the extent that there is AI, if you choose to call it that, it really isn't AI so much as it's pattern execution. So the entities are supposed to kind of like do specific sets of actions that the player predicts. Like it knows, you know, that this kind of entity, when it sees you, like charges at you or whatever. And you know that like this other kind of entity like randomly waits some amount of time and then like pounces at you or something, right? So there shouldn't be any like AI in the game that's you know, doing something that could be considered like intelligent, because that's would ruin the feel. Like the feel is supposed to, it's supposed to be like arcadey, like an arcade game, not like an immersive like simulation feeling thing. Are you offended that they missed the opportunity to name the cat Purgatory? I'm not offended, but I do agree that that would have been a step up, right? Purgatory is great. Catsy Purgatory, also great. I mean, who could argue with that? And again, the AI thing, just to be clear on that, that's a stylistic decision. It's not a technical decision. It's just the type of game that you're making. If you're making an arcade game, you generally don't want to specify a lot of things that, like, the goal of artificial intelligence generally is to sort of confound the player to a certain extent, meaning it's supposed to feel more like you were playing against a human, right? So it's supposed to make decisions that maybe you don't necessarily exactly understand, or maybe do things that might be considered clever, or respond to your behavior. And those are not things that I want in this game, meaning like nothing in this game should be like learning about what you are doing or taking actions based on expectations about what you've done in the past. And those are the kind of things that you would normally consider AI. And this game is not supposed to feel that way. It's supposed to feel like the things in the world are very like simple organic beings that just have a particular reflex, right? They're very like innate, and they just only do exactly what you would expect them to do. And the difficulty in the game comes from you trying to look at a particular screen, go, these are the patterns that I know will occur, so I'm going to do this because that's the most effective way to thwart those patterns or accomplish the objective I'm trying to accomplish, given that I know those patterns will happen, right? And of course, it's not always possible for the player to really be that thorough about it, because as you get enough enemies on the screen, their patterns become fairly unpredictable to a certain extent as well. So that chaos is fine too. I'm not saying that we have to keep it so that the player can perfectly predict everything's going to happen or anything. But generally speaking, it is supposed to be the case that like if it's just a player and one or two entities, they should not have to guess about what's going to happen. There should be very clear, like, oh, I know these things patrol back and forth, and I know this thing will charge at me when it sees me, and that should be the way that the player is reasoning about the world. That should be very consistent. And if that's ever not the case, it should only be like one. Maybe there's like a specific type of entity that was smart. If we ever did any AI at all, it would only be like very specific for some. I don't think we will, because I can't think of any reason why I want that in there. But it would be a very isolated incident if we put in anything that would be considered like an AI style thing. Let's see. You're fairly optimistic in your expectations for the serious thing you don't expect to be done for 2 years. What are some of the topics that have taken longer than expected? Actually, nothing's taken longer than expected, and the 2 years is right on target. The only thing that I messed up was when I was computing the 2 years, because I said two things. I was like, 600 episodes is how many we're going to do, so it'll take 2 years. For some reason in my head, I was like thinking 300-ish days a year of episodes, so 600 is 2 years. But we only do either 5 or 2 episodes a week, depending on the circumstance, which means that it's more like 5 or 6 years to get 600 episodes. So we're more or less exactly where I thought we would be, which is to say that we're on episode 485, and I said there'd be 600. I still think that's roughly how many there'll be. I might be more or less, if there was 700 episodes, I wouldn't consider myself that far off in the estimate, but that's just the reality of doing it this slowly. Normally you program many hours a day. Here I get 4 hours a week. It's just not very many hours. So I would say, yeah, there was really no optimism. It was pretty realistic, and so far it seems about right. We'll see where we are at on day 600, if I was in the ballpark or not. Maybe we're on day 600 and we're nowhere near done. How do you approach redrawing small parts of the screen in an immediate mode GUI? Well, immediate mode really doesn't have anything to do with whether you're redrawing a small part of the screen or a large part of the screen, right? It's just how you decided to iterate. So in an IM GUI, right, you've got a structure, and you have a way of looking up where you are in the structure that is code rather than data, right? So at each branch where you go, I'm going to draw this panel now, you can just do a lookup to say, do I need to draw this panel now? If the answer is no, you just don't touch it, right? Another way to say it is you do it exactly the same way that you would do it in RM GUI. They're really not different. They're just different APIs to the same system, right? An IM GUI is a different interface, but it doesn't imply a different structure. You could create a complete... In fact, I've often said, you can take an RM GUI library and create an IM GUI interface out of it. I've actually done that. I did that once for a Qt app. where you could IM, have an IM interface, and then what it would do is it would build the structure out of the IM calls, look at the structure that existed in Qt, and modify all the things that it needed to basically sync them together, right? So IMGUI is an interface paradigm. It's not an implementation paradigm. The implementation can be anything you want, and if you want something that's more retained in terms of implementation because you've decided that's better, you can just do it. It's really not complicated. The goals you said are trying to inspire the next generation of game engine programmers. How successful do you feel the series has been on that front? Remarkably successful. Far more than I thought it would be, actually. I receive emails. So I kind of buried my email address because I was getting so many emails from people about the series and them going into game programming or getting a job in game programming because of the series that I just got overwhelmed by them. So I buried my email, and even with the email, there's only one place to get the email now, and it's in it's a business email. I still get email routinely, every week, from people who are like, I got a job doing low-level programming after watching the series and this sort of stuff. So it's been way more successful than I thought it would be, which is great, I think. I mean, it's hard to know how necessary it is to have low-level programmers in the world, but from my perspective, we need a lot more of them. So having people getting into that and getting jobs and doing it for a living, I think, is really good, personally. Toxificated. Could you please explain again what does volatile do? Sure. Volatile is a pretty simple concept, but it's very widely misunderstood, largely because people, I think... So in that same way that low-level programming is not very common these days, people tend to think of things dogmatically or in terms of abstract concepts they've been told, not in terms of what something actually does, and that makes it very difficult for them to understand something like volatile, because volatile is not really an abstract concept. It's very concrete. So volatile tells the compiler that the piece of code it happens to be compiling at that time is not necessarily the only one that will modify the value in question. And that is all it does. So if I say int x, and the compiler is compiling code that references x, the compiler implicitly assumes that the piece of code it's compiling is the only thing that is touching x. So if it compiles the code x plus equals 1, it assumes that the value before and after that statement are whatever x was, and then whatever x was plus 1. Right? If you insert a volatile, so you have a volatile int x instead of a regular int x, now when the compiler compiles that code, it assumes that the value of x after x plus equals 1 is arbitrary. Who knows what it is? It knows that it will write back the x plus equals 1 to the location where x belongs, and then it will have to read it again to find out what it is the next time x is referenced, right? So volatile is a way of preventing the compiler from making assumptions about the values of variables that are marked volatile. And it tells the compiler that every time you operate on a value marked volatile, you must read it into a register and write it back out again after you are done, because other people are simultaneously modifying this thing. That's all it does. So it's imperative to recognize that when you're doing multi-threaded programming, you need to use volatile in a lot of circumstances, because you need to tell the compiler it cannot rely on the value of this thing being the same as it was because other threads are touching it. But it's also imperative to understand that that is the only thing that volatile does. Volatile does not synchronize access to that variable. So you must still use locking or locked operations in order to access that variable, because otherwise you can get race conditions if you don't know what you're doing, right? So volatile is one tool in a set of tools necessary to make multi-threaded code work properly. And it's crucial that you understand what it does and does not do. If you're doing multi-threaded programming. If you're not doing multi-threaded programming, you never need to know what volatile is, ever. It's completely unrelated if you're not doing multi-threaded programming. However, multi-threaded programming can sometimes mean things you don't think it means. For example, if there is hardware in a system and that hardware is sort of effectively executing its own threads and can modify values in main memory, that is a case where volatile might be important, right? So you may have, like, to give a very simple example, let's suppose there's a keyboard controller that operates asynchronously on a particular piece of hardware, right? So you don't have to call a function to read from it or do anything else that would clue the compiler in that it could change. You just know that the main memory contents may spontaneously change to reflect the fact that a key was pressed, right? Well, there's another case you need volatile, because if you don't tell the compiler that this memory range could just be spontaneously changed by somebody, then the first time you read it, it may just think, well, I know what it is, and I know that no one's changed it, so the next time I read it, I don't need to read it again. I know it hasn't changed, because I'm looking at this piece of code I'm compiling, and I can see we're in a loop here looking at the space of memory, and I know that no one's touched it, because I'm looking at the code and no one touched it, right? So again, multi-thread can mean more than just the threads you write. It includes any type of execution unit that exists anywhere in the system, right? An interrupt handler, an asynchronous piece of hardware, a separate bus that can reach over and touch main memory. All of that stuff would induce volatility, and things that have that characteristic must be marked volatile in order for the code to work. Otherwise, the compiler may accidentally compile out work that it should have compiled in because it thinks something can't change when really it can. Hopefully that makes some sense. Pulp user, with explaining the meow hash question, I aimed less at the implementation, but the thought process that goes behind it. Do you know of a good resource to read up on how hashes are generally constructed, how you design them so they produce low collision rates, and how do you quality check them? Actually, no, I don't. So the interesting thing about hashes is they really aren't well understood, in my opinion. So basically, there's two types of hashes. There's cryptographic and non-cryptographic. There's some work that has been done on cryptographic hashes that has to do with things that you might be able to do in terms of proving their strength. And that, in a sense, is a way of looking at hash design that is systematic. But the kind of hash that meow hash is, which is a practical hash, non-cryptographic, there really isn't much known about good ways to implement those because the definition is bizarre. The definition of what makes a good hash for non-cryptographic purposes is one where the data that is expected to hash will not collide. Right? Because fundamentally speaking, what you're talking about when you talk about a hash is you're talking about a compression function. It's a function that compresses a large amount of data, usually, into a small amount of data. So it's something that takes, I don't know, 10K of data and represents it in 128 bits. We know from information theory that there is no way to represent 10K of data, any set of 10K of data, in 128 bits, which means that all hash functions are equally bad. I'll say that again, all hash functions are effectively equally bad. Why? Because information theory tells us that every hash function is exactly as bad as representing its inputs as every other hash function. Now, I'm not an information theorist, so correct me if I'm wrong on that, but that's my read on information theory. There is no way to construct an arbitrarily good hash function. They are all equally good or bad, however you want to look at it. They all have exactly the same arbitrary provable quality, which is to say that all of them are bad at representing data, because there's no way to represent 10K data in 128 bits, right? Now, I should couch that a little bit to say that it's not really true, because I could write a function that I call a hash that just returns 0. And obviously that's worse than a hash that actually returns all 128 bits worth of possible data. So what I should say is there is sort of a way to assess a hash function and say that some hashes are objectively bad because they are unable to produce an even distribution from the distribution that comes in, right? Meaning that all of the messages that come in, if almost all of the possible inputs to the hash all map to 0, that's objectively a worse hash function than one that can actually produce a message that maps to all possible 128 bits. So there is one way you could look at a hash and say there is a quality that you would like to get, which is that you want to use all possible 128 bits worth of output, right? Because if you don't use the complete range of output, then your hash is objectively worse than a hash that did. But assuming that your hash can produce all possible values of the 128-bit, 64-bit, 32-bit, whatever the output of the hash is, assuming that that's true, then they're all equally bad. And the reason that they're all equally bad is because each one maps the input message space redundantly somehow onto that set of 128-bit values. Whether one of them is good or bad for a particular purpose just depends on which set of messages you will input to the hash, because I can always take a given hash and pick messages that will collide, right? And furthermore, the number of messages that will collide should be the same for every hash, right? Because you know that the total number of outputs of the hash is 2 to the 128. That means that the number of collisions for every hash that can produce the full range of 128 bits of output is the same. They all have the same number of collisions. So the only question is, do they have the same number of collisions on the data we care about? So that's what I think makes hashes particularly hard to reason about non-cryptographically, because non-cryptographic hashes are about what are the chances that the types of data you will feed to it will collide. And we have no idea. Who knows, right? I mean, the way to look at it would be we'd need to take a large corpus, see what the sorts of structures of the messages are that are in that corpus, and then say which hashes do a good job of spreading those out very diffusely so that changes that are likely to occur between two similar messages will result in different 128-bit values. I mean, that's really it. So there's some properties that we can say probably are ones we want. Generally speaking, we would want a bit that changes in the input to change all the bits in the output, or as many of them as we can make happen, right? We want messages that are the same but in different orders to produce different hashes. Things that we can generally say are true about the kinds of inputs that we're feeding it. That's really all I can really say. There's not a lot more that I feel like you can really say in the abstract about non-cryptographic hashes. Cryptographic hashes are much more well understood in a sense. And the reason for that is because they have a real model for what they're trying to prevent. A cryptographic hash is trying to prevent someone from spoofing a hash value. So what they're trying to do is look at how difficult it is to work backwards from a particular hash to a particular input or set of inputs. That's actually much easier, in my opinion, of a problem statement because you actually have some idea of what you're trying to do. A non-cryptographic hash is both easier to make by accident than a cryptographic hash and harder to define rigorously. There is no attacker in a non-cryptographic hash. We don't know what their motivations are, and we certainly don't know how to look at a function and tell what a non-cryptographic hash really needs to do, right? And so while it's true we could just say, well, a cryptographic hash probably has to have properties that would be good for non-cryptographic hashing, so in that sense they're sort of equivalent. In a sense, that's really not true. Like, we don't really have any real reason to think in that way. It just kind of happens that if it's hard to figure out collisions, then therefore it must also be unlikely that they could happen by accident, I guess, right? But it's just really hard. And I think that problem is, it's just non-cryptographic hashes are just a really ill-defined problem, because by definition their goal is to make it unlikely that particular corpuses will collide. And that's just not very well defined. It's just an intrinsic property of the corpus. You could almost think of non-cryptographic hashes a lot like image filters. They're good if they work good on the images that you have. I mean, that's what they are. And it's very similar to compression. Like I said, compression is good if it happens to do a good job compressing the input. And that's all you can really say about it. There's a few little parts of it that follow the same thing as like the hash, where you can look at them and say, well, given that we want to encode some set of symbols, then we can say things about the optimality of the encoding. And the same is true for hashes. If we decide that we want, generally speaking, modifications of bits to affect all the bits in the hash, we can then say how good a particular hash is at doing that. But that doesn't speak to whether the thing is effective for the particular corpus, really. Right? And so it's just it's much like compression, it's just a very ill-defined concept, and there's a lot more black art to it, I think, than science, really, although obviously there is some science to it, exactly like compression. So that's what I'd say. All that being said, I'm not a hash construction guy. I happened to figure out a good hash. It was largely luck. Looking through the rest of the questions here. Do you happen to know how different embedded C programming is compared to simple C programming? They're basically the same, except for you have more hardware constraints, like timing, number of cycles that you have to do things in, the amount of memory is tightly constrained, and so on. But in other ways, they're a lot more fun, because you know exactly what you're doing. And I like that. One of the most annoying things about programming on Windows is specifically that I, A, don't know how much memory I have to work with, B, I have no idea how cycles are counted or how they're going to be applied, C, I have no idea when the operating system is going to interrupt me, D, I have no idea what else is running on the system, and blah, 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 blah. So embedded programming is actually a lot more satisfying, even though it's more limiting, because sometimes those limits are very refreshing. You know what's going on, and a lot of times you have a lot more control over the system. So I would say that it's 6 to 1, half dozen of the other. There are some parts that you don't get to do, like you can't just allocate huge blocks of memory and party on it like we can on a Windows machine, because you always have just gobs and gobs of memory to work with. But you do have situations where you know how much memory you have, and you can make decisions about it, and it's reasonable. You don't have to show up and go, well, there might be this much, there might not be this much, I don't know, the operating system might be doing this, it might be doing that, right? Patchpart, would adding a fund section on Handmade Network be a viable short-term solution? Handmade Network is already funded by a fund. It's right here. The Handmade Hero Fund, or the Handmade Fund, I should say, allows you to contribute, and we have been funding things. CDBG would definitely be next on our list. The problem right now for it is I don't think we can provide any realistic amount of money to them that would really help at this point. The Handmade Fund just isn't big enough for that. Right now we traffic in a few $100s. It would need to be several $1,000s before we could really provide anyone what would amount to be a living wage for doing things like CDBG. So we have this option available. The level of contributions for stuff like that just isn't that large. Tuscated, I understand, thanks. I just wasn't, talking about the volatile. I just wasn't sure because the wiki says do not use it for inter-thread communication. Yeah, so I guess what I would say about that is there's a lot of misinformation floating around there about volatile. If you want one of the main reasons to treat Stack Overflow as a purely random resource that may have some things to think about but never take it as actual answers, if you look at the kinds of things that are said about volatile on there, they're almost all wrong. yes, it is true that volatile doesn't solve your inter-thread communication problems, because that's not what it does. It is also not true that it isn't for inter-thread communication. It absolutely is. Volatile is a crucial component of inter-thread communication, and without it, inter-thread communication won't work. If you're trying to say to have two threads that need to share access to a particular piece of information, it had better be marked volatile. Otherwise, the compiler may just compile it straight on out, right? So it's crucial to understand what it does and it doesn't do. It is a very important tool for multi-threaded programming. It's just not the only tool. And so I think a lot of times when people get confused is they've been warned about volatile not doing everything for them. That's not the same as saying it's not necessary. It is. But no, it doesn't solve the problem. It's just one part of the solution to an inter-thread communication problem. Lori Master, a really good lossy compressor is a decent hash function. Absolutely. That's 100% correct. You could think of a hash function as a very, very lossy, but hopefully good lossy compressor. Long Billion, you mentioned many times that you're not a game designer and that it would be ideal if John Blow would design the game. Do you plan on having him on an episode or two to talk about gameplay related stuff, specifically related to design? He seems to be a very person. I imagine proper game design does not just happen in like a day or two. Yeah, so no, I am not planning on doing that. And specifically because that's not really the hard part of game design. So, you know, the extent to which John could contribute abstract guidance to the game is stuff that I could do myself. Because that is not hard. That's more like game criticism or game reviewing and game thinking about games. And that's actually stuff I'm comfortable with. The part of game design that is hard and the part that, for example, John excels at is the actual work of experimenting and deciding on experiments in the game. And that is not something that you do by having someone just take a look at something and make some comments, right? That's not what that is. And so I think it would be great if John did streams where he shows how he does game design work in that way. That would be a wonderful educational resource, but it would be in-depth and it would be involved. It's not a 2-day thing. It's a many-day thing showing lots of hard work being done. Just like the engine work in Handmade Hero. It's significant. It takes a time investment, very specific expertise and skills. And it's not something you can just drop by for a day and do. That's not what that is. See if there's, we're pretty much at the end of the stream. I don't know if there's any. Martins, there are attackers for non-crypto hashes. Hash table lookups can lead to denial of service attacks when attackers can control the data coming into a system. Well, so I would classify that as a cryptographic hash, though. Like, if you have an attacker, it's a cryptographic problem to me. So I don't think of that as being a non-cryptographic hash. If you're using a hash for purposes related to data that an attacker can control, then you have a cryptographic hash scenario, right? That is what that is. So it's no longer appropriate to be choosing from a non-cryptographic hash, period. That's my opinion on it. Obviously, Martins, your opinion may differ, and I would totally respect that, but that's just not the way I think of it, if that makes sense. So I almost think of the definition of a non-cryptographic versus cryptographic hash is, are they suitable for use in a case where there's an attacker? And so attacker in this case means anyone who can cause damage to the system by controlling an input to the system. And that totally includes data coming in for a denial of service attack, right? I don't know if that makes sense, but... Meowhash is based on AES, so in a way it uses crypto tech. Yeah, so the way to think about that would be AES is the cheapest instruction on a current CPU that can mix bits, and that's why it uses it. So it definitely uses crypto tech, but doesn't really necessarily use them in a crypto way. And so while it does take advantage of the S boxes in order to get propagation of bits out from individual bits to 128-bit lanes, I have taken no care to try and make sure that that happens in a cryptographically secure way. So it is assumed, at least by me, although I have not undertaken any sort of attempts to prove it, but I don't believe that there is therefore any cryptographic security to it, because the way in which the AES bit mixing is used in Meow Hash is not cryptographically secure. In fact, I'm fairly sure it's cryptographically insecure, meaning that someone who wanted to reverse the Meow Hash process probably could, or could at least in some circumstances. And so it's not equivalent to the way that AES is used in a cryptographic scenario at all. All right, let me just take last questions here. There's too many questions. The SM hash or GitHub repo talks about percentages of bias and distribution for a hash. What do those mean? So it depends on what exactly you're talking about in any given part of a hash test suite. But generally speaking, what we mean by bias and distribution is that you have an input to a hash, and then the hash outputs its hash value. Usually it's compressive, but sometimes it's not. So sometimes you can hash 8 bits and turn it into 128 bits, right? The Meow hash, for example, supports every size from 8 bits up to 2 to the 64th, right? So who knows? But generally speaking, you're typically hashing more with a data hash anyway. So you're typically hashing at least a few K, maybe a few megabytes even, or even gigabytes, depending on the circumstance. And you're turning it into 128 bits. So what we talk about when we talk about bias and distribution is that if you look at that input, if I want to talk about a specific bit in the input and I change that bit, right, then there's a question about how those bits might correlate to other bits, to bits in the output, right? So if I change a bit in the input and I look in the hash output and I see that like only one other bit changes, you would say that that has a lot of bias, or that the distribution is very bad, for example, right? Because it means that certain ranges of your inputs produce very predictable ranges in your outputs. Does that make sense? Whereas if I flip bits in the input and just random bits change in the output that seem to have no correlation to which bit I'm flipping, or no predictable one anyway, you would say that that's very unbiased, right? Or that it has a very good distribution. If I feed a bunch of inputs in and they all come out totally randomly, I can't find any correlation. It's distributing very well, right? So basically the idea is just to say that depending on what you're measuring, and bias and distribution could be used in different ways when you're talking about hash. It depends on exactly where they were using it. But generally speaking, what you're analyzing is that set of correlations. I have a certain set of inputs. I'm going to make a structured series of changes to those inputs. I'm then going to look at the distribution of hash keys and see hash outputs and see whether there's a bias to them. Well-distributed outputs imply that there is not a bias, right? Because a well-distributed set of outputs should not let me identify correlations to things I'm doing the inputs, whether that's flipping bits, changing the order of things, right? And so on. Jonathan Blow made an offhand remark that one should never use the standard I/O functions, but always use OS-specific I/O functions. I do not know why, and I can't stop thinking about why it could be. Do you know why he could be talking about? Do you know what he could be talking about? Thanks. You would have to ask him for his motivation for saying that, but obviously there's a lot of reasons not to use standard I/O functions, and the main reasons not to use standard I/O functions usually are because it's an extra layer of indirection that could do all sorts of things that you may not want to do. Number one, when you're actually creating a data stream of some kind, most of the flags that you're provided via standard I/O don't map exactly to the I/O flags of the actual hardware that's underlying, not the hardware, the operating system that's underlying. So for example, if you're going to call open or fopen, you will have a much more restricted set of options that you could use, generally speaking, than if you call create file on Windows, which gives you a lot of other options, right? So that's number one, is indirect mapping that reduces functionality. Number two, There may be buffering or unwanted transformations of the input or unwanted copies of the input that are unnecessary introduced by the layer. So if you call, for example, fopen and then you use fwrite or fread, you will oftentimes be going through an intermediate buffer, which just adds an extra copy for no reason that is not necessary, right? And so typically speaking, you don't want to do that for no reason, because unless you actually want the buffering, you're just wasting the CPU's time and making your I/O slower for no reason. Number 3, you're using resources that don't actually need to be there. So if you take a file pointer that's opened by fopen or a file descriptor opened by open, that's necessarily maintaining a table or a structure interior to the C runtime library that itself then has to maintain a pointer to the operating system's version anyway in order to issue the real calls. So essentially what you're doing is you're creating a management layer that's using up extra resources and taking extra time, extra cache space, etc., for doing nothing other than forwarding your I/O functions to the correct actual place, right? Those are some reasons. Don't know whether any of those were the ones that he was thinking of, but they might be. All right. Thank you, everyone, for joining me for an episode of Handmade Hero. It has been a pleasure coding with you, as always. If you would like to follow along the series at home, you can always pre-order the game on handmadehero.org. It comes with a source code, so you can play with it yourself and, well, learn from it, add features, do the sorts of things that you might do with experimental programming. That's about it for this week. I'll be back next week when we'll take a look at getting our art asset structures, having the correct sort of alignment and sizing stuff in them that we want, so that when things get imported into the game, they look correct for multi-part entities, which is really what we're missing at the moment in terms of placing entities. That's about it. Hope to see you back here for that. Until then, have fun programming. I'll see everyone on the internet. Take it easy, everybody.